Yeah.
Hello, Arav.
Hello.
Hello. Hi. कैसा है?
Uh, hi.
But can you just briefly introduce yourself?
Yeah. Hi, I'm Arav. I'm a Sophie in the mechanical engineering department, and I've been interested in quant since the start of this year. Uh, After Winter School of Quant, that was the first time I was introduced to uh, quant finance and making alphas and algorithms in general. Then after that, I participated in a couple of competitions with my friends, and we performed well, and so that increased my interest in general. Other than that, I like doing robotics and like watching F1
Like one thing?
with fun.
Sorry,
I like watching the sport.
F1.
Yeah.
Right, right. So what did you do in Winter School of Quant?
Yeah. So I didn't like properly do Inter School of Quant, but I watched a couple of sessions that introduced the brain platform, and they gave some example alpha. So I tried that.
So did you created any alpha by yourself?
Yeah. Yeah. Like using the like I explored the operators and the data fields and tried combining them in different ways, and adding some constants or changing the settings, uh, like the group neutralization or the delay and so on to improve the shot.
Do you remember any strategy you made? Any hypothesis?
Uh, so I read about this indicator called CCI, Commodity Channel Index. Like this is one that comes to mind. Like uh, you take high plus low plus close divided by 3, uh, and then you take the SMA of that, and you look at the so this is roughly the CCI, and you see how many standard deviations away from the mean the CCI is. So if it is uh, decently away from the mean, then you say it's oversold, and if it's not, then it's over. Like if it's in the opposite direction, then it's over.
Sure. So did you like coded this on the brain platform?
Yeah. So I use the trade when operator, and like
Hmm.
so if that is greater, like if it's some standard deviation away from the mean, then you trade. And I think I added a couple of more things like volume based on the volume. I don't exactly.
And what was the sharp fitness?
Uh, I don't like. I think this was one of my better alphas. So the sharp was like close to 2.
Hmm. Can you explain me the formula of sharp and also share your
Sharp
screen?
is uh, okay. So sharp is like the risk adjusted return.
Hmm.
Yeah. So sharp is a risk adjusted return. So the total returns divided by the standard deviation. And there's like this factor of root 50, 252 as well, because that's the number of trading days.
Correct. And what is drawdown?
Drawdown is, if I remember correctly, it's like the maximum loss you have made with the alpha.
Right. With the P, with respect to the P.
Yeah, with respect to the.
Can you explain me some of your projects which you did during your IITB
Uh, Related to quant or in general?
in general?
Uh, so during this
The main
summer,
projects.
yeah. So during this summer, uh, from like June to July and so on, I made two ITSPs. One was a maze solving bot. So it was a micro mouse. If you have you heard of micro mouse?
No,
Okay, so it's like wait, I can. They are like small maze solving bot
hmm.
like this. Veritasium has a good video on this. Uh, so essentially, I had to design the like first we chose the components for this, uh, and then we had to design a PCB, like a two-layer PCB. And since this is very small, you have to like like put all the components, and you have to design the components very in a very optimized way. And then we did the routing and so on, and then we placed the components. And so we had actually initially we had planned to use an FPGA for this because it's faster. So we bought a Chinese FPGA board called the Tang Nano 20J because it was like we thought we could do it. But after like trying a lot, the documentation was very bad. So we had to like look at the documentation on Baidu, like the Chinese website, and translate it. But still, like we like I am in mechanical department, and one of my friends is in the aero department. We two were doing this, so we couldn't get enough documentation, and like we didn't have enough experience to actually use the FPGA. So we ended up switching to the Raspberry Pi Pico, and then we made like a small maze in TL to run this bottle. And yeah, so and then there are like other things in the code itself we optimized. We looked at other designs because this is a very popular thing. So there's lots of designs available open source. So we looked at them and how they're doing things.
Hmm. So you coded this in Verilog or VHDL or some other language?
Yeah, so for the FPGA, yeah, so we in the end we didn't do the FPGA, but when we were trying,
Hmm.
we so the FPGA on the board was from this company called Govin.
Hmm.
It's a Chinese company. So they have this Govin ID. So yeah, then we use Verilog, and they had some like some IP soft cores. So we tried that. Uh, there's a simple RISC-V 32-bit core. We tried that, but
Got it.
like it was unreliable. So if we had to actually do it, we would have to do it in like pure Verilog without using the software, like soft cores, IP soft cores.
Hmm. Uh, okay. So what did you do in Summer of Quant?
Yeah, so in Summer of Quant, I followed the Notion page, the resources roughly, and
Hmm.
in the end, the final project, I tried like 3 or 4 different strategies with different indicators and compared their performance. So I think uh, one of the strategies I tried was that since like so in Summer of Quant, we had to like the final project, it was to make a strategy for trading Bitcoin. So Bitcoin is very volatile, like compared to normal stocks or other things. So the mean reversion trend is like it's good if we do mean reversion. So I use the RSI indicator to see oversold and overbought conditions. And so if the RSI goes above 30, I start buying. And then if it crosses to over 70, I stop buying. And
And did this work?
yeah, yeah, and also I added this indicator called like this volatility indicator called average true range.
Hmm.
So it takes the maximum of like 3 values. Like I don't exactly remember, like highest high minus close and some other things. And using that, you can using the average true range, you can put like a stop loss. So if it's very volatile, you stop trading.
Can you show me the code for this and
Uh,
just explain me the whole?
yeah, 1 second. Yeah, I think it is. Yeah, it's this.
You wrote it by yourself or this
No,
is
like I gave the strategy to
hmm,
cursor, and then
hmm.
like I made some tweaking. But actually, I don't remember which one was which. Yeah, strategy 2 was the one I was talking about.
Hmm.
Yeah. So Yeah, so the overall idea was this, but I think I had incorporated other things as well. So I think, yeah. So there's like different scores I kept for the trends, for momentum, and yeah. So the momentum was based on the RSI and MACD. MACD is like the moving average convergence divergence. So you take the EMA 12 minus EMA 26, and then that is your MACD signal, and then you take the EM of that itself. So if that uh, the 9-day EM of that, so if that crosses over the MACD line, then you're bullish.
Uh,
Uh,
And what is this deep RL based trading strategy? Yeah, go on. You were saying something.
Sorry, you're not.
What is this deep RL based trading strategies in search?
Oh, okay, yeah, that was FinSearch. One second. Uh, so uh, for FinSearch, there's this paper uh, on using deep RL to do stock trading. So for that, like I read that paper and tried to like re-implement that paper. So do you have like a basic uh, knowledge of what RL is?
Yeah, I
Or
have, but just go from basics.
okay, so in reinforcement learning, essentially it's a form of machine learning, but like let's say in supervised learning, you have the data set and you have the target variable, and you train a model and you compare the predicted value with the target variable to get the loss function, and then you do backpropagation gradient descent to optimize the model. But in RL, like the reward is not so sorry, the target variable is not so well defined. So there's an agent and there's an environment, and the agent has certain actions it can take in the environment, and based on those actions, you give it a reward or like a punishment depending on like how those actions perform the way you want them to. Or not. So RL is traditionally like earlier like I think DeepMind did a lot of the initial development like in reinforcement learning. I think close to uh 2014 15. Yes. And they trained a lot of
So
RL
how did you
to play a
use
lot of
RL in your
games.
trading strategy?
Right. So uh, for that, I defined an sorry, a state space. So state space is what defines the environment. The state space at the value of the stock, like of the total stocks, and some indicators as well. And the action space that the agent could take was like buy or sell each stock, like assign weights to each stock, and like depending on that, I'll distribute the total balance I have into the different stocks. And the reward was given based on the returns, based on the risk adjusted returns. Uh, Other than that, there's also some like other heuristics, like if the market is too volatile, then you stop the agent. And what else? There's like one or two more things, but then I try different RL algorithms on the on this environment that I created based on the paper, and it did not perform very well. Like if you just did buy and hold, it's like only a little bit better than that. So I have to improve that.
And which all algorithms did you use?
So I tried DQN, Deep Q Network.
Mhm.
That is like what the paper used. It used other algorithms as well, but it's the most popular algorithm for finance RL. So should I explain what DQN is?
Yeah. Go
So it's like there's a non-deep version, which is the Q table based uh, RL algorithm, which is like a very simple algorithm in which you uh, like uh, you update the like you maintain a Q table of like in this state taking this action will give me some expected reward. Like there's a table of states and possible actions. And so taking this action in this state will give me a possible reward. And you update that reward based, update that expected reward based on the rewards you get as the agent trains. And then finally, when it's trained for a particular state, you look at possible actions and whichever one has the highest expected reward, you take that action. So deep queue network is essentially you're using neural networks for this now. So uh, there are two networks. One is like the policy network, and one is the the value function network, I think. And you let the agent take some steps in the uh, based on the policy network. You let the agent take some steps in the environment, and then you you see like yeah. So once the agent has taken some steps in the environment, you can compare the value that the policy network gave you for the expected reward with the actual reward that it got. And based on that, you update the value function network. And I think every few passes, you make these two networks equal, something like that.
And why do you think it didn't perform?
Uh, because like I hadn't. One thing is that like uh, you need to run it like RL requires a lot of compute to actually perform better. So I had to run it for a long time. I didn't run it for that long. That is one thing.
Do you think RL-based strategy would actually yield something in trading?
Uh, I think it could like eventually if you use a like a better algorithm with more compute and with better data as well.
Mm.
So like the data was basically the stock data of the uh, top like I don't remember top 20 or 30 stocks from the Nifty, and I use some indicators. So the data also if we refine the data better, like add some normalization, because the stock data it's not very well suited for an ML algorithm, right? You have to normalize it, you have to do some refinement and all that. So that could be improved. Then I guess the RL algorithm will perform better.
Uh, how was your experience in Munich? What all did you do? What all are you doing?
Sorry, your voice like it's like not
Uh,
clear.
what all did you do in Munich? And how is it going?
Hmm, like, sorry, it's just
In
like
Munich,
I can't
Munich,
hear you in the middle.
Munich,
Oh,
Munich.
Umic. Oh, yeah. So one second.
Is there a lot of noise through my?
No, I like it's just your voice becomes low, like the volume reduces. And
Okay.
yeah. So in Umic, initially I did some projects in the training period. So we made like a bamboo copter, a 3D printed bamboo copter. So there we had to choose the airfoil. There's a software called XFLR5. So we use that to perform some basic analysis of the airfoil, uh, like compare the drag coefficients and uh, uh, other things based on it. And then we chose to use two airfoils and merge them. And then we designed the model in Fusion 360 and we 3D printed it. And we performed some analysis. Like we also used ANSYS to do some CFD or not CFD actually, just static analysis to see if if it was not too weak. Uh, Other than that, the main thing I'm doing is I'm in the perception subsystem.
Mm.
So we handle the computer vision and the SLAM part for the drone, for the autonomous drone. So
Who's
the
your manager in
one
perception?
Daksh,
And only one manager.
uh, yeah, I think actually like a lot of people 30s, 40s left last year, like in Europe. So the main lead, he's a main lead. There are other team managers, like, but they're not like subsystem specific. So
Yeah,
in
you can go
perception,
on.
yeah, we are currently participating in a competition called Robust Foraging. Like it's a competition hosted at New IPS.
Mm.
So in that, uh, there's a environment, and wait, I think it's better if I just. So there's an environment like this, like a Unity environment, and you get visual data uh, for the like. So essentially, it's like you have to write a visual encoder for an RL algorithm that will navigate the environment to get to the target. So it's like,
So
and the main thing
how
is
is
that
it very different from the racing team, IIT Bombay's racing team? Isn't that the same thing? Like navigating and making a self-driving car?
uh, so first thing is that here it's like a racing team has like a nice environment, like they have cones
Hmm.
and so on, like on the track that they have, and the environment is usually clear.
Hmm.
Here we are only, and also they have like lidar and other sensors as well. Here we are only getting visual data, nothing else.
Right.
And the visual data itself is also noisy because of the fog and rain and so on. So so you have to make a visual encoder that is robust to these changes. So there's this technique in computer vision called domain adaptation or domain generalization. So we are trying to explore that, so that like uh, what it aims to do is that you generalize the model more. Like usually if you see that let's say the model has been trained to identify a mouse or like some object, right? So if you look at the representation in the like the latent space of the model, then it will uh, put those things, like let's say there's object one and object two, uh, and I have a photo of object one and a photo of object two, and I also have a painting of object one and a painting of object two. So ideally the painting of object one and the photo of object one should be closer, right? Because they represent the same thing. But what happens is that the photos are closer and the paintings are closer, but like so uh, what you actually want is for it to uh, semantically learn the same thing, but not uh, in terms of how it's represented. So we are trying to work with it.
Um, do you have any experience in competitive programming, DSO? Do you do that stuff?
Uh, I haven't like uh, I tried a little bit in like the end of second semester. Like I participated in a few CF contests,
Hmm.
but after that I have not done it.
Do you want to try one? No.
Sorry.
Do you want to try one?
Uh, sure.
Yeah, this is the chat section.
Yeah. So I've understood the question. Uh, can I get a minute or two to think?
Yeah, just think out loud. Speak whatever you have.
Sorry.
Just think out loud. Speak whatever is coming.
Okay. 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 So we need to use the coins to get the sum. And one thing we can do is like uh, start with the smallest number and add it until like the one thing I've learned is like permutation is considered as a different way. Uh, and like you can use the same coin multiple times. So one thing that's something to mind is like you keep adding two till the sum exceeds 9. And then like so 2 plus 2 plus 2, 6, then 8, then 11. But so after it's exceeded 9, you go back to the previous one. That's 8.
Right.
And like since 2 is the smallest number, like there's nothing that can fit between 8 and 9 that is in this set. So you go back like one more iteration, and then there's 6, and then you can try the next one. That's 3. Then you remove one more 2.
But how will you count for 2 to 3 2? That combination. The permutations are considered different.
Sorry.
The permutations are considered different. So 2 to 3 2
Yeah, yeah.
is also a permutation.
Yeah. Okay, so you could like start iterating. Uh, so first you start with 2, and then in that iteration, like there's another loop inside that loop, which again goes through these, and you keep adding the numbers. So it's like uh, so so there's an outer loop which is like you iterate over 2, 3, 5. Then there's another loop inside it which also iterates over 2, 3, 5. Okay, wait. Then I think I'll have to use some sort of recursion. So the number of ways to 2, 3, 5 is like the number of ways to get the sum 9 using only 2, only 3, only 5, and then 2, 3, 3, 5. And okay. I think recursion can be used, but I can't like think of a proper way to do it yet.
Yeah, recursion is the right action.
Sorry.
Recursion is the right action. The first coin will either be 2, 3,
Hmm.
or 5.
Yeah.
So think now. That gives an
Right. So the first coin will either be 2, 3, or 5. And then the rest, like, so 9 minus 2, like 9 minus 3, 9 minus 5, something like that. So there's a function that returns the number of ways you can do it.
So
Would
basically f of
9,
9, which we want is f of 9 minus 2 plus f of 9 minus 3 plus f of 9 minus 5.
Yeah.
Yeah. And the base case is f of 0 is 0 and not f of 0 is 1 and yeah, f of 2 is 1, f of 3 is 1, f of 5 is 2. Okay, so have you done any probability questions for quant?
Not not really, not that much.
Okay, try this one. See the chat.
Bullets are loaded into a gun's round barrel consecutively. The barrel has a capacity of 6. Gun is fired once, but no bullet is shot. Does the does rolling the barrel before the next shot increase the probability of firing a bullet? So so we assume that like shuffling it will like rotate it in any random way. Like what I think is if shuffling it will like just put the two bullets in any random position, then like it doesn't. It's like we are back at the start. Am I audible?
Yeah, no, no.
Yeah. Like my question is that like let's say you fire it once, there's no bullet that is shot. Then you rotate it, then it's like it's back at the like you're at in
Yeah,
a random position, right? So
yeah.
the probability would be the same as before. Is what I think.
So what is the answer? Should you roll or should you not roll?
Oh, okay. Right. So after you fire it once, I feel like the after I fire it once and no bullet is shot,
Hmm.
then the probability of uh, a bullet being shot in the next round is higher. But if I roll it again, so I feel like yeah, it should be higher.
So you should uh so you should roll it or you should not roll it.
Sorry, I meant lower. So you should roll it. Yeah.
You should roll it.
Yeah.
Okay, and can you calculate the probabilities?
So initially when before the gun is fired, the probability of a bullet coming out is 1/3. After the gun is fired, I think the probability will be 2/5 because okay, not really. So the so I'm just not able to think of how to quantify the probability after it's been fired once and no bullet is shot. Like a proper way to quantify.
So if you shot and there was no bullet,
Yeah.
though there was no bullet which came out, so it will have so the bullet the barrel was positioned at one of the four white
Yeah. Yeah.
slot,
Yeah.
right?
Let's say this one. Yeah.
Yeah, and the probability that when we go to the next slot there is a bullet is uh, is 1/4, right? Because it will have to be either in the 3, 4, 5, or 6 if you number it. Let's
Yeah.
say the top right one is 1. So 1, 2, 3, 4, 5, 6. Initially, uh, we were at either 2, 3, 4, or 5.
Yeah.
And at the next time, we are at 3, 4, 5, or 6.
Yeah.
So only when we are at 6, we will observe a bullet,
Yeah.
right?
Could you repeat the last part?
It is given that during a first shot, no bullet came out of the gun.
Yeah.
So it will, so the barrel has to be positioned at one of the four white slots,
Yeah.
and only one of the four white slots will give the bullet next time, only the last one, because otherwise the
Yeah.
first three won't give any bullet the next time.
Yeah. Yeah.
So the probability is 1/4.
Okay. And if we roll the barrel,
Then it's
then the
1/4.
probability of it's 1/3. Okay.
So you should
So
roll
it
the barrel.
okay.
See the answer.
Okay. Yeah. So shuffling makes it from 1/4 to 1/3.
Okay, so Arav, tell me one instance in which your project was going out of the track
Project
and
was
you was going out of the track
okay.
and you made it on the track again.
Out of the track is in like it was not going in a proper direction or like we are faltering. Uh, and I guess you could say there's we participated like me and three other friends. Project or a competition works as well, right? We're participating in the International Quant Championship, like IQC by World Quant. So initially we were like uh, not that high. Like think we had all collectively submitted roughly 6, 7 alphas, and like we are not that serious. Like you're not seriously submitting alpha because like I realized that if we want to seriously like get a good position for the next round, then we should like consistently submit alphas every day, at least like one alpha to get the 2000 points. Uh, but like everyone were like busy with some work or the other, and so we could not like uh, submit. Like we are all not serious enough to submit one alpha every day. So, but then like I decided that like we had to do something because uh, not many people in IIT Bombay were participating in the competition, and like it was an easy way to get a good position. So then I started submitting alphas. Like I submitted 2 3 alphas one day, and then I also asked them to submit. So then that way we got like more motivated to submit. Like essentially, I submitted more alphas than them. So they also started submitting because they saw me submitting alphas.
Okay.
And we looked at different resources online. We found some GitHub repositories that had some alphas. So we tried to reuse those alphas, modify them a little bit, and so that's how we got like cleared for round one. Unfortunately, like in the next round, we could not like submit many alphas, so we didn't go after.
What did you didn't like in your past experience, and what is your ideal next year?
So you mean like what I did not like in our attempt at IQC this time, right?
No, in UMIC.
In UMIC.
Yeah, tech team.
Oh yeah, so tech team. What I don't like about it.
Mm.
So essentially, our training was supposed to get over around January. We joined around November, and our training was supposed to get over around January. But the main people who are managing our training, like I think there are 2 or 3 people, 30s, they suddenly just left the team without like actually handling their work properly. And so like they're like very there's no one in charge of the team. So they are like very vague deadlines and like no one was very serious about it. And then in the winter as well, sorry, not in the winter, in the summer as well, like we were supposed to come back to the campus and actually like work on a competition. But again, like because of the lack of leadership, uh, not much was like done. Like the I think the lab also got damaged a little bit during the summer. Like I think the roof fell down because of the rain. So not much work was done. But now after we've come back, uh, like I have tried to do as much work as possible. Like I go to the lab many times, uh, and I've set up like a Discord server as well, like racing team has. So initially, like earlier, there was communication on WhatsApp and it was very scattered. Like there's like if you search Aero on WhatsApp, I saw like 5 or 6 groups for different things, and like everyone sent messages in random groups. So then I decided to uh uh like one step in like more seriousness towards the team itself is like setting up a Discord server and having like weekly meets, and in fact like multiple meets during the week to discuss work, like discuss the competitions. So I set up poll on the group how many people want to switch to Discord, and almost everyone agreed. So then I set up a Discord server and coordinated with everyone to switch to Discord. And then after that as well, I have like tried my best to continuously look for new competitions and like try different things.
And if if you come into quantity, then there will be like 3 to 4 hours of commitment each day, right?
Okay.
So how do you plan? Like you will have it will clash with UMIC. So do you plan to leave UMIC or what?
Uh, okay. 3 to 4 hours a day. So that's like 20 to 28 hours a week.
Yeah.
Okay. I think that's like a little bit higher than I thought. I thought it was like 15 hours a week roughly.
Okay. You can estimate, yeah, yeah, 2 to 3 hours. So yeah, for 5 days or 6 days, yeah. For 6 days, 2 to 3 hours is 12, 18 hours.
Uh, so
When
I mean,
hackathons are coming close, of course, it will increase to
yeah,
3 to.
I can manage time. I mean, like I have been doing other projects with Humid, like like I did the ITSPs and a couple of other projects as well. So I know how to manage other things with Humid.
But won't that create like uh, like the other members are fully into quant. So and some people, if they get only partially involved in quant, won't that create some mismanagement and like a lack of context to the one who is not participating as much?
Uh, like I'm not saying I'm not participating as much. I will try my best to participate equally as other people.
Okay. Um, what is your ideal next
Ideal next.
tech team?
Uh, what do you mean by next technique?
Like whatever the problems are there in UMIC,
Yeah.
if you want to join another tech team, hypothetically, then what is your ideal next tech team?
Uh, I mean, like I don't I don't consider quant team to be a tech team, right?
Yeah.
Yeah. I mean, I like the work going on in racing team, but they don't recruit so much. I have a couple of friends in racing team, autonomous division, but they don't recruit so much. So like I think we can like get back on track in aero itself if we try.
Mm. Uh, when do you get a sound sleep? What happens during your whole day that after the day you get a very good sleep?
Uh,
What is one thing that after doing that you get a very good sleep?
uh, that's hard to say. Like it depends on the day itself. If I feel like I've done enough on during the day, then I feel rest. Like I can rest.
What is the hardest problem you have solved till now, and how did you solve it?
Yeah.
Just think 30 seconds. Like hardest problem, not academically, but in general.
In general, I think like problem in what sense? Like so you don't mean like a puzzle or
No, no, no. In life, what was the situation? What is the hardest problem you have solved till now?
I can't like it's hard to suddenly recall. Uh,
Yeah, yeah, take your time.
Again, like what do you mean by solve a problem in life? Like I had problem in like so you don't mean like in a project or in an academic setting.
No. It can be a project, it can be academic setting, but whatever was the hardest problem you have encountered in your like 18, 19 years of your life.
Because I don't think of problems in terms of hardness. Like I don't compare because the problems are so different in different cases, so it's hard to compare the hardness. Like there's been multiple times. Like I can't think of one like specific instance where I feel like it's the hardest problem I've solved.
Just tell me one instance.
Uh, Because I don't remember the exact specifics is the problem, like of any.
Okay, good. Uh, Next one is 37 into 73.
Uh, Sorry, I'm just sort of startled. Give me a
48 into 62. Next question. 48 into 62.
uh, three 384. I think.
48 into
Sorry,
62.
sorry. I'm just panicking a bit. Can you like give me a second to? Yeah. Same question or
79 into 93.
uh, 7347.
Tell me a moment where you made a meaningful and a measurable difference, and tell me why did it matter. Again, it can be anything uh, in life in general, where it was your actions and it was you that made an impact in that situation.
Okay. So in the summer we participated in this hackathon, me and a friend, called like a Scribbler JavaScript hackathon. It was a hackathon where we had to like there's this interface online JavaScript uh, notebook, and you have to make a project. Like they're given some ideas, and based on that, we have to make a demonstration or a useful app or something like that. So we didn't put much effort into it, and we thought like we wouldn't get selected for like the. So the first round was just submitting the project. The next round was presenting it in front of the judges. So we didn't think we would actually get selected, but then somehow we got selected, and I just like looked at the message just 1 or 2 hours before the actual presentation. So we were panicking. Like we've not done that much work here, and there's like how would we present it in front of them in a meaningful way? So like I quickly decided to look at different projects related to it and the different algorithms that we could have used, and quickly made like a small uh, like a website that shows the like that summarizes the project itself. And we quickly prepared a script, and I motivated the other person as well, that like we have enough confidence and knowledge to present it in front of the judges without like fumbling. And so we ended up getting third in that hackathon.
So, okay, Arav, that's it. That's all what I wanted to ask.
Okay. uh, I had like a question, like the quant team is like not very public. Like I searched on the internet, I couldn't find much. Like I couldn't find anything at all, like related to quant team or like what work is exactly done. Will you just like elaborate a bit?
Yeah, so this is the second year of running Quanti. So, what we are planning to do is will have we will create some in-house uh, trading strategies which we'll focus on. Mainly that is our target, and also take part in 3 4 flagship hackathons. Like one will be IMC Prosperity.
Yeah,
Uh, one will be one recently happened Quant Challenge by Five
yeah.
Rings. Yeah, and 2 3 more we are thinking which to focus on. And Apart from that, this is a suggestion which will get implemented at some time, but we will have some subgroups of one subgroup hand knowing more about market making, one subgroup knowing more about arbitrage, uh, that sort of stuff.
I actually tried participating in IMC this year. Like,
Prosperity?
Prosperity 3. Yeah.
Yeah. So what was your rank? How did it?
So we like I searched online and I found strategies of past years winners. Like there's this guy called, I forgot his name, but he's made like a nice back tester like that everyone uses. And like he has a strategy public, and I think some other people also had their strategies. So we tried to mix and match the strategies for the first round, and I think we got like a decent position, uh like 200, like top 200 in the first round. And after that, I think it was very close to the end sems. Like it was like some weeks before the for the second semester. So we tried like a little bit, like we didn't do that much effort into it. But in the end, so, yeah, in the end, our rank was like 600 something. Got it.
Here's your question.
So what has been done till now in the quantum?
What has for the past when we participated in a hackathon called Zelta Labs Hackathon. So it was a 3 month long hackathon in which we had to make some strategies for trading in the Bitcoin market, Bitcoin and Ethereum market. Uh,
Okay.
and then we participated in IMC Prosperity. Then we are now making the whole structure of what we want everyone to know about how to make a hypothesis, how to make a trading strategy, how to backtest it without overfitting on past data, what is a Markovian way of testing, what is Monte Carlo backtesting, and then also make some uh, then of course after we have studied some theory, then we will focus on making actual strategies which we will actually put our money in. So this is the path will which we are making up right.
Like what did you do in prosperity? Like
Mm.
what
So
was
we
like?
were yeah. So I think we were ranked 137 globally and 26 in India. Yeah. We can discuss the specific details of the trading strategy later.
Yeah. Okay.
That's it.
So, yeah, you had told me to think of a project.
Oh yeah. What was the project which you think of?
So not exactly a project. There's this a competition sort of called Numer AI. Have you heard of this?
I don't.
Sorry.
No, I haven't.
Okay. So so essentially uh it's like a crowd fund, like crowdsourced hedge fund. So they give you like an anonymized data, and you have to uh, train your model on it. So there's no, it eliminates all the finance uh, indicators and all that. It's just data, anonymized data. Uh, and you have to train a model on that to predict the target. And based on how well, you can also, they have their own cryptocurrency called NMR. Uh, and you can, if you have confidence in your strategy, you can stake NMR against your strategy, and you can earn like money that. So they have this
That,
tournament, and people continuously submit models here, and
mm,
they can earn money as well.
that's something interesting. Actually, we can even try uh, having this in fund.
Yeah. Uh, so like this sample ones they've given in docs is like they've trained some light GVM models and so on. on the data that they provide. So it's just like anonymized data. And it's also backed by Coinbase and Renaissance. So like big so we can like think about exploring this, like try submitting some models, see how it looks. Yeah. This I feel is similar to there's this Kaggle competition last winter uh, on like by Jane Street. Like that is also sort of similar. Like they're given anonymized data and we have to filter it to generate signals. I think. Like, did you participate or like hear about this?
Green Street one, I knew, but I didn't participate.
Okay.
The quant challenge problem one was similar to this, right? If you had a chance to see it. Same 17 columns, uh, unlabeled data. So not unlabeled, anonymized data, and you have to make a model predict the vibe.
Okay. So I feel like this is like the exact opposite of World Quant. So World Quant, you have no ML models, only financial indicators, and you have to like generate alpha. This is the opposite. You have no financial indicators, only ML, and both
And
ways you earn money.
this one makes more sense, right? And World Quant
Mm.
Brain, I don't like it much because
Yeah.
yeah, it's very abstract. You have to figure out some hypothesis. You have to use their operators. Okay, Adam. So
Okay. Thank you.
the